Welcome to Trajectory Part 4, what I'm calling Advanced. We're going to look at a problem you're not likely to run into in a high school situation. But I think we should take a look at it to, first of all, let you know these things exist, and number two, to show you how we can use everything you've learned so far. In this situation, we have a quarterback throwing a football at an angle of 50 degrees with a velocity of 10.0 meters per second. The ball travels downfield like it always does in a parabolic curve, strikes the ground at some angle final and some velocity final. Now these are different. This angle and this velocity are different from these two. The reason is this velocity, as you see, it takes more time to come down than it does to go up. So this vertical velocity at this point, v sub y, will be greater than the initial vertical velocity. And this angle will be different because the ball travels a little bit farther downfield. Now, just to keep everything squared in your head, the time it takes to go from the initial throw 2 meters off the ground to the top of the arc, we're going to call the time it takes to go up. And the time it takes to go from the top of the arc to the ground, we're calling that time down. Now, I think it's obvious that this time down will be greater than the time it takes to go up, only because there's a greater distance to travel. All right, first thing we're going to do is what we've done before, v sub x, resolve the vector, cosine theta, v sub x, 10.0 meters per second times the cosine 50 degrees. And hopefully you've done this enough so you don't need to see me work this out. Velocity in the x direction is 6.4 meters per second. V sub y, v sine theta. These are exactly what we did in the very first trajectory video. Giving us a v sub y initial upward velocity of 7.7 meters per second. Hopefully there's nothing here you haven't seen before. Next question. How long does it take to get to the top of the arc? We're looking for this right here, the t in the upward direction, from when the ball is released 2 meters above the ground to the top of the arc. And we're going to go back, use our standard definition of acceleration. Minus 9.8 again because the object is slowing down. Final velocity, top of the arc, is 0 meters per second. Initial upward velocity is 7.7 meters per second. And we're looking for the variable t. Again, we've done this enough times where you don't need to see me do the arithmetic. We get 0.8 seconds. Next, how high is this? When I say high, how far above the 2 meter height is this arc, top of the arc? And we're going to use our standard s sub y equals 1/2 at squared plus v sub yt plus s0. Now this time s0 is not 0. S sub y equals 1/2 minus 9.8 meters per second squared, again, because the object is slowing down, times the amount of time it takes to reach the top of the arc, 0.8 seconds squared, plus initial upward velocity of 7.7 meters per second times 0.8 seconds, plus the initial 2 meters. The object was above the ground when it was released. And again, you've done this enough times, so s sub y is 5.0 meters. That means the top of the arc right here is 5 meters above the ground. Okay. Next, we're going to find out how long does it take to fall to the ground. S sub y equals 1/2 at squared plus v sub y t plus s0. S sub y we just calculated, 5.0 meters, 1/2. This time 9.8 is positive because the object is accelerating times the time squared. V sub y and s0 are both 0. Gives us a time of 1.0 seconds. Pretty straightforward, pretty simple, I think. Okay, now, next question I have for you is how far downrange does it go? What is s sub x? It's nothing more than v sub x times the total time. How long does it take to go out to the top of the arc and back down? S sub x is 6.4 meters per second times 0.8 seconds plus 1.0 seconds. Remember we did two separate time calculations? It takes 0.8 seconds to reach the top of the arc, 1.0 seconds to fall to the ground from the top of the arc. Gives us an S sub x. How far downfield does the ball go? 11.5 meters. All right, it's a pretty good throw, 35 yards. Let's take a look. We're going to calculate next. We're going to know what the we're going to calculate the downward velocity like this when the ball hits the ground. That's pretty simple. Fall back in our A equals delta V divided by delta V. Pardon me here for a second. A little ahead of myself, and sometimes I do things I shouldn't. Delta V divided by T. A is 9.8 meters per second squared, and that's positive because the ball is accelerating. The final velocity we're looking for, the initial velocity is 0. The object is at rest at the top of the arc, and the time it takes is 1.0 seconds. So our final velocity, coming straight down, the v sub y on the way down when the ball hits the ground, is 9.8 meters per second. Right. Now, question is, what is this velocity right here coming down here at this angle? Well, knowing that situation is like this is v sub y, this is v sub x, this is v final, this is theta final. We have a right triangle. We know v sub x, we calculated that above, and we know what v sub y and the way down is right there. V square, v sub x square, plus v sub y square, v square equals, let's see, 6.4 meters per second squared plus 9.8 meters per second squared. So it gives us a final velocity of 11.7 meters per second. Now, what is this angle theta? Well, we can just say, we know from our trigonometry that the tangent of theta is equal to the opposite divided by the adjacent. So the tangent of theta is equal to 9.8 meters per second divided by 6.4 meters per second. Tangent of theta is equal to 1.5, and theta is equal to 56.9 degrees. Now, how do you get here? Well, on your calculator, you have something that might look like this, or something that looks like this. Both of these are the arctangent and the inverse tangent, and they both mean the angle whose tangent is 1.5. And this is the final answer. So the ball strikes the ground at an angle of almost 57 degrees at 11.7 meters per second. I hope that helped. Now again, please take a second, if you would, leave a comment. Let me know if this helps any suggestions for changes or anything that's not clear. Thanks.